Revise what we have done so far. We started this thing by considering that what we have already looked at in the previous lectures. It all started with charge, and now that charge transfers thing will be explained through one of the you can say component of the circuit, which is called capacitor.
Mm-hmm.
So we're gonna talk about different type of capacitors, how charge is actually being transferred from one plate of the capacitor to another plate, and what is the loss of that energy. Also, we're going to talk about that how we can make capacitor charged and discharged. We'll talk about that also. So I just said that what is conductors? So conductors are basically those things which has that free electrons, and those free electrons can transfer themselves so that they can conduct electricity or charge, to be precise.
Mm-hmm.
So free electrons are something which is present in metals only, but in electrolytes there is ions which makes electrolytes conductor in nature. So that is also that is also you should know about. So whenever we see a conductor, so that conductor must possess these free electrons, and these free electrons can any time if they find any situation to relocate, they will relocate themselves in order to gain or lose energy, like
Mm-hmm.
in order to achieve stability. So in this way, we can say that if electron get transferred, then some charge is being transferred. So we
Mm-hmm.
can also calculate that charge which is going to be transferred between the plates or the conductors. Some charge is going to transfer, so we can say mass transfers during that transition.
Mm-hmm.
So let us assume that there is a plate, there is a capacitor in which there is some charge transfers takes place. So that charge transfer is going to look like if initially they had Q charge and Q charge. After some charge being transferred from this plate to this plate, like from 1 to second, then this plate will eventually get some more charge and this plate will lose charge.
Mm-hmm.
But how this situation is actually going to represent? By Q minus delta Q, assuming delta Q is the charge which is transferred. So this plate will have a different charge in this place. This plate will also have a different charge. So we are going to
Mm-hmm.
calculate each and everything here in this lecture. Let's start with potential and voltage. Now, before actually studying capacitor, we are going to understand that how battery works. Because if we understand that how battery transfers the charge, we can actually understand how capacitor get charged or discharged. What does it actually means? So in battery, let's start it from the basic. Like in your middle school, you must have seen that battery is something which is represented by this symbol.
Mm-hmm.
This bigger plate is something which carries positive charge, and the smaller plate is something which is used to represent negative charge. And the
Mm-hmm.
difference between these two plates, potential, is something called potential difference. So if we actually try to understand that what these plates are, we will automatically understand that how charge flows. So this is something which we generally see in chemistry. Like suppose this is a container which contains two electrodes. These two electrodes are basically cathode and anode. Do you know what they are?
No.
Like you must have studied in chemistry.
I've seen these terms, but I forgot because I did chemistry like 2 years ago, so I don't really remember that much.
So these two plates are basically electrodes. Electrodes are something which can release or which can gain some charge. Like it can lose as well as it can gain some charge from the solution. So battery is something which is a combination of two electrodes and some solution in it. These two electrodes will some because of the solution, like which kind of electrolytic solution it is. This cathode or anode may lose or gain charge automatically based upon the reaction. Like this is
Mm-hmm.
something which is completely chemical and there exists a chemical reaction, and that chemical reaction is something which is completely chemistry part. But for us, what we can assume is that this cathode or anode, whatever it is. So let me just explain you the actual behavior also. Cathode is something which loses charge.
Mm-hmm.
Anode is something which gains charge. Like how this two electrodes work. This is what I'm explaining. So this cathode will eventually lose its charge into this solution,
Mm-hmm.
and through this solution, this charge will reach to this anode, and this is how anode gains charge.
Mm-hmm.
Until the time this procedure works, like the capabilities of these two electrodes work, the battery lasts. This is what happens in a battery, which you actually used so many times before. Like whatever batteries we are using in remotes or anything which actually requires batteries like toys or something. These
Mm-hmm.
batteries are actually the combination of these things. Two
Mm-hmm.
electrodes in them, some solution. So whatever amount of charge they will lose or this anode gains, it is almost equal always. Like whatever
Mm-hmm.
charge it will lose, it will gain the same. And it will uh, this process happens till the time when this cathode might has lost all its charge, which it was capable of losing. Then
Mm-hmm.
the battery stops working. So I was talking about potential difference. And this potential difference is again something which exists for these two electrons. Like when it is keep on losing charge, whatever charge it lose, like this is the charge lost, is directly proportional to the potential exist. Like whatever potential there be between the batteries, it only depends upon it how much charge the battery has lost, or
Mm-hmm.
you can say the electrode has lost. So this is how a cell works, and this is what we can say the voltage exists between the plates of the capacitor, not
Mm-hmm.
capacitor, battery. So all the diagram which I have shown in the previous slide is supposed to be shown here, but there are different type of batteries you can say, and here the type is something which depends upon like the capacity. So in different kind of automobile, you can say, an instrument, you can say, a small device. It completely depends upon that which kind of battery or which amount of battery is actually going to use for these different things.
Mhm.
It is also based upon their sizes. Like if it requires higher capacity to store or use, you can say, energy. So it completely depends upon their size. So there's an electrolytic solution, and these two were supposed to have that electrodes, which is something called cathode and anode. So for positive electrode, the word is used cathode. Cathode is something which loses charge. Remember it. It
Mhm.
can lose charge to the solution.
Mhm.
Now finally we came at capacitor. That what capacitor is, why it is so common, why we are using this capacitor in almost like every device. So question answer to this question will be given and understand by actually understanding that what capacitor is. So basically capacitor is a two-terminal electric component to be precise. It is
Mhm.
two-terminal electrical component. Electrical component is something like which is being used in every type of device, or you can say the circuit. What capabilities it has? So the major capability it shows the ability to store energy in the electric charge form.
Mhm.
Capacitor is a device which actually stores electrical charge as a form of energy.
Mhm.
So let me just give you an example. Maybe I gave you it in the early classes also. So generally what happens is this is what it is very common and usually experienced by almost every type of generation because this is something which is based on human behavior. So whenever the remote which we are generally using doesn't work or stops working, this is the remote. So what it does is it tries to hit it with something. And for a moment it clicks,
Mhm.
or you can say it works. So during the process, what happens is that there is a capacitor in it which looks like that.
Mhm.
It works because of capacitor. So capacitor is somewhat arrangement of two metal surfaces. These metal plates were supposed to have same area. Like in area, in terms of area also they need to be same. And they must be separated by a distance. They must be
Mhm.
separated by a small distance. In that small distance, there might exist a, a medium or there might exist only the air. So it completely depends upon that what kind of capacitor it is and where it is actually going to used. Because
Mhm.
on that thing only, it's what inside is something which is decided.
Mhm.
So generally what happens is these two plates of the capacitors carry certain charge and that charge which they carry, they will generally One has positive Q and the other has negative Q. Equal charge, but of different nature. So these two plates have equal charge, but of different nature. And because of that only, there exists electric field. This is something which we studied yesterday only, like how electric field works and looks.
Mm-hmm.
So what is the basic behavior of electric field? That why it is existing here? Because if there exists a charge and that too at rest, it will generate electric field. And we saw the field lines and everything that how they looks.
Mm-hmm.
So if there is a positive charge, there is a negative charge, there exists an electric field. This is what exists between these two plates. Like whatever strength of that charge is present on this plate, that type of, or you can say to that magnitude of electric field will exist between these two plates. So the ability of storing charge also increases.
Mm-hmm.
So depending upon that only, they are used in different type of objects. Like
Mm-hmm.
this is the very small example. In the clock we uses that AA batteries. So the clocks have that energy source as those batteries. So those batteries, when release charge, that charge is something which is being stored by these capacitors before actually giving it to the circuit.
Mm-hmm.
Like you can say, like we can say that batteries are connected with capacitors. This is how they look. This is battery, this is capacitor. So this battery releases charge, and before actually sharing it with the circuit, this capacitor is connected in the beginning, and this capacitor will do that it stores charge in it first. So they will get a charge, and that too of equal magnitude. And then there exists an electric field between them. So it gets some charge, and before actually sharing it with the circuit, capacitor first stores charge on its surfaces. And because of that, there exists a electric field between the plates of the capacitor. And strength of this field will decide that how much charge it can actually store. Then the charge goes to the circuit. So
Mm-hmm.
this is how it is connected between the circuit and the battery. So capacitor is something which is drawn through this symbol in the circuit, like which symbol is this?
Resistor.
Exactly. So you are familiar with this symbol. Similarly, for capacitors, we use this symbol, like two parallel lines. This is so whenever I'm representing a capacitor in a circuit, I'll be using this, and this is how it all things work here in the capacitor.
Mm-hmm.
So now we will try to find what is the capacitance of the capacitor. Like how can we actually measure it? So it is generally measured in terms of microfarad. This is how it is represented. And that capacitance C is something which is calculated using the basic behavior. Like
Mm.
whatever charge it can store is directly proportional to the potential that exists between the plates. Suppose this plate has VA potential, this plate has VB potential.
Mhm.
So that charge which exists between these two plates is directly proportional to the potential difference of these two plates. Are you getting at this point?
Yeah.
So when this proportionality thing is removed from the equation, we get that Q is something which is equals to CV, where C is capacitance of the capacitor. That is something which is constant,
Mhm.
proportionality constant it is. So it is calculated in or represented in, or you can say given to a capacitor in terms of farad, which is the unit of it. So this farad, or you can say F, like one F is not a small number, you can say, a small quantity. It is a huge quantity. Why I am saying this? Because we uses microfarad in the circuits. So this is a big
Mhm.
quantity. So like this is something which is representing that capacitor is something which can be created for any instrument or any system, that how it is worked.
Mhm.
So that Q is nothing but charge between plates of the capacitor, and this is potential
Mhm.
difference. Now, one more thing. This potential difference, that how much potential difference exists between the plates of the capacitor, will actually depends that which battery is actually being used to charge it. Like
Mhm.
if it is 50 volts battery, so from the positive plate, the plate which is connected becomes positively charged,
Mhm.
and the negative plate which is connected to whichever metal plate will become negatively charged.
Mhm.
So this potential difference is again, which is something because of the battery, and this is something which is sometimes given and sometimes we need to find in the question. So capacitance is something which is calculated by Q by C, and its SI unit apart from Faraday is something which is Coulomb per volt. So this is the component of the circuit which I like studying for the very first time in 12th grade only, because a normal person don't needs to know these things, like whatever it
Mhm.
exists. But it makes a little we make a little aware about the everything we actually use. It will also make us asking ourselves every time when we find something inappropriate, or you can say it is something which can be questioned.
Mhm.
So capacitor is a device that stores electrical energy, or capacitor you can say is a pair of two conductors of any shape also. So the capacitance doesn't depend on shape of the conductor. Like whatever shape we can use here, these two plates.
Mhm.
This is an important point. And the net charge on the capacitor is always zero. Like capacitor
Mhm.
is something is neutral.
Mhm.
As delta Q, or you can say Q net is zero. Actually, there is no charge. It is neutral. but still it can crane, it can do so many things for us. Capacitor is also something which doesn't use energy for itself. So actually we are not losing anything. But in most of the appliances, it is connected in such a way so that it can protect that appliance. Like
Mm-hmm.
you can see, there are so many appliances, uh, like whatever, microwave, my refrigerator, you can say television, AC, air conditioner, geyser, whatever it is. Every device has capacitor, and that capacitor actually protects that device from alternating current, which our houses get. So we
Mm-hmm.
don't use direct current as a source of energy. We use alternating current. So what capacitor do is when suppose that alternating current which generally flows like that. So that alternating current when comes to an appliance and sometimes you can assume that the wave which it is carrying it becomes very uneven or like its magnet increases or something like that happens. So what we will see
Mm-hmm.
here is that whatever extra charge or energy that wave is carrying, that extra energy is being absorbed, or you can say it just bursts itself. The capacitor will diffuse itself in order to stop that supply of charge to the appliance.
Mm-hmm.
It absorbs or uses that energy somewhere to protect that appliance. So
Mm-hmm.
that is the reason that every appliance, like everything which is being made or which is being used, has that capacitor in it, which uh, generally gets all that thing done.
Mm-hmm.
So sometimes we see that the old appliance may get uh, defected or something that they are not working well. So we just call their technician or electrician, whatever it is, to get to make it fix to fix it basically. So we observe that they just change something out of it, and now it is working well. Like what was
Mm-hmm.
that thing which generally got diffused? It is that capacitor only. Most of the cases, not always. So one unit is farad, and the smaller SI unit which we use millifarads, microfarads, nanofarads, and even picofarads.
Mm-hmm.
This is this is nano. You must have seen it, right?
No.
Like these terms.
Oh, well, not Pico, but yeah.
Uh, Sometimes there are certain terms which we are not aware of, but they're kinda which we know already.
Mm-hmm.
So 1 millifarad is 10 to the power minus 9 farad. 1 microfarad is minus 6. 1 nano is 10 to the power minus 9. 1 pico is 10 to the power minus 12. So this is
Mm-hmm.
something we call stat farad, another unit. So one particular thing may has more than one unit to measure them because it depends completely upon that in which device or of what capacity is actually made of. So it depends upon that only. Now
Mm-hmm.
then there exists a dimension. Are you aware of dimension thing?
Um, no.
Like can you recognize it? Like anywhere if you have seen these things like this representation.
No, I haven't seen this, like, what that is. I've never seen that.
All right then. So this is something which is being, you can say, for every quantity we define, we can represent it in terms of the seven fundamental quantities which is being used here also, like mass, length, temperature, and current.
Mhm.
So on the basis of these four quantities, we just gave this capacitance a dimension, which is like its identity.
Mhm.
So without actually looking at the name, by looking at it also, we can identify that it is nothing but capacitance.
Mhm.
All right. So now you just tell me which is more dangerous, a capacitor or a battery?
Hmm. I think capacitor
Why?
because it no, actually,
It's batteries. They are more dangerous. Haven't you seen such cases where a electric car just explode or it just got burned
mhm,
or the battery present in it exploded? But
mhm,
you won't heard about this for the capacitor because this doesn't has any charge, but it can store it. So batteries are more dangerous. Like there are so many factors on which the batteries it actually depends. What is the safe zone of it? So temperature is the major factor, and that major factor is the reason of so many mishappenings around the globe. So capacitance of capacitor with or without dielectric. Like here you can say that capacitance which is not seen here between that like this. So it also depends upon like its capacitance is something which depends upon like this space between the plates.
mhm,
So if somehow we just fill the space with some sort of material which actually like give more strength to electric field to exist. Like we just add something in between the plates of the capacitor that it will strengthen the electric field that exists between them, and ultimately it will help it to store more charge.
mhm,
So by filling something like dielectric, this is something that is called which is being poured in between the plates of the capacitor. That is dielectric. It is something a material which helps in increasing strength of electric field.
mhm.
That strength of electric field, if it increase, it will ultimately increase the charge capacity storage. Yeah, that's the storage capacity of charge.
Mhm.
So there is some mathematical thing also about it. So I don't think so we should go into it. But yeah, the basic thing that exists, you should know about it. So we have parallel plate capacitor. Generally, whatever type of capacitor we actually see, they are most of the time parallel plate only. Like there exist two parallel plates. But there are some other configurations as well. Like they are cylindrical in nature also that exist.
Mhm.
There also exists a spherical capacitor, like sphere within sphere, like cylinder within sphere, cylinder within
Mhm.
cylinder. And there exists a parallel plate capacitor also. So let us assume the charge it can store is Q, and they are separated by a distance D, and the area of the plates of the capacitor is A. So capacitor has that capacitance, which is nothing but epsilon naught A by D.
Mhm.
So capacitance of capacitors is generally more if they had more area, like size. This thing is actually gonna emphasize on size of the capacitor. Like more the area of the capacitor is, so it will have more size automatically. So the bigger capacitor we will have.
Mhm.
And it is inversely proportional to the distance. Like if we reduce the distance between the capacitor, their strength increases.
Mhm.
So the relation we got for capacitance is nothing but epsilon naught A by D. Epsilon naught is something which is there in K. Now tell me what was K? Where we studied it.
Mm, it is it the force? No.
In electrostatic force, there exists a K which is proportionality constant, and this is something which is 1 by 4 pi epsilon naught. So that epsilon naught is something which is there for the
What's a
capacitors also.
silo knot?
Epsilon naught is permittivity. Permittivity is something you can say that how much force it can allow, how much a medium can allow a force to exist. That is something called permittivity,
Mhm.
like giving permission to it. So permittivity of
Mhm.
space, that is epsilon naught, and there also exists the epsilon naught. Like
Mhm.
if there exists only air, so epsilon naught is nothing but it is equals to 8.85 into 10 to the power minus 12. So we need to remember its value also because this value is something which is not given in the question when we are
Mhm.
solving numericals. And that is something also which is represented by K. If it is filled with dielectric, so we can assume that the capacitance must be increased by K times.
Mhm.
And that C is nothing but this without any medium. Epsilon naught A by D with medium this times K, that is dielectric constant.
Mhm.
Let's move ahead. Again, these are important things, so you should remember them.
Mhm.
Capacitance, all about capacitance. Now let us do one question based on it. And let's see what we got. A parallel plate capacitor with air between the plates has a capacitance 8 picofarad. So there exists a capacitor which has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half and space between them is filled with a substance of dielectric 6? So first of all, let us remember the two formulas. First is for capacitance epsilon naught A by D. And second, if there is dielectric, then capacitance will increase by the factor of K. All
Mhm.
right. First of all, we'll try to calculate the capacitance. So capacitance here, it would be 8 picofarad, which is given. So we will write this thing in this way, like 8 into 10 to the power minus 12 is equals to, I have written this,
Mhm.
epsilon naught. We don't know the area, so we write it as A, and distance between the plates as D only. Then
Mhm.
it is asking what will be the capacitance if distance is filled with, distance is reduced by half. So for the next equation, it becomes CA by T reduced by half, so it will be divided by 2. And space
Mhm.
between them is filled with substance of dielectric constant 6. Means it must be multiplied by 6.
Mhm.
So let us write it and see that how this factor changes. So it will become 12 epsilon naught A by D, right?
Mhm.
So 12, what is the value of epsilon naught A by D? Given in the question only.
Yeah. 8 times 10 to the power minus 12.
Or you can say 96 picofarad.
Oh.
So we need to remember these two relations in order to solve questions from capacitance thing.
Mm-hmm.
This is something which you will do as a part of your homework when you are
Oh.
revising these things. Then there exists the grouping of capacitors. So capacitors is something which is being connected in a circuit in two forms, either series form or parallel form. For series form, they exist like this. In parallel form, even I should draw capacitor only, not the resistor.
Yeah.
In series, it should be looking like that, and in parallel, they should look
Mm-hmm.
like that only.
Mm-hmm.
So this is what series combination is, and this is what parallel combination is. So if you try to solve the series combination here, we would have said that there exists a battery which is connected to these capacitors. That is
Mm-hmm.
the battery which is going to supply the charge. So when the battery supplies the charge, so that charge is something which is common for both the capacitors. Battery can't supply
Mm-hmm.
charge different for different capacitors, irrespective of their capacitance, because
Mm-hmm.
charge and potential is same. So we can say if the charge is constant here, look at this thing very important. If the charge is constant in series combination, so potential must divide across all component in the circuit.
Mm-hmm.
In the circuit, all component means like whatever type of another capacitor, resistor, or any other component is like put. So there exists a potential drop across this and this also. So we can
Mm-hmm.
say that in series combination, the potential is something which divides, so the total potential of the battery must be equals to the potential drop across both the capacitors C1 and C2.
Mm-hmm.
So now we will rewrite the equation in terms of capacitance and charge. We have just studied the charge which stores in the capacitor is something which is equals to C times that capacitance times the potential difference.
Mm-hmm.
So from here we can say that the potential difference is